Good day, guys. I hope you're all good. Today we are going to be looking at this analytical geometry question. So we have question 3 here that reads as follows. It says that in the diagram below, the coordinates of A, B, and C are given. And AC is parallel DE and CEB is a straight line. And then another thing that we are given is that D is the midpoint of AB. So the first thing that we know, the coordinates are given. We also know that AC is parallel DE. It means that this line here, which is AC, this is the line AC, it is parallel DE. We can see this by simply looking at these arrows here. It means that these two lines are parallel. Then another thing that is also given here is that D is the midpoint of AB, right? So D, it is the midpoint of AB. So let's take a look at D here. D, it is the midpoint of AB, right? Another thing, or another way in which we can see that D indeed it is the midpoint, we can see by this here. What does this tell us? It tells us that AD, it is equals to DB, right? So that's what we can see here. So now going forward now to our next question here, which is the first question. It says that we should determine the length of AB, and we must give our answer correct to 2 decimal places. So what do we know so far from this line that they are referring to? They are referring to line AB here, which is this line here. So what do we know from line AB so far? We know that D, it is the midpoint. Also know that AD is equals to DB, and we also know the coordinates of A, we also know the coordinates of B, right? So meaning that now we can use these 2 points to find our length or our distance. So the length that we know that it is AB. So from this we know that since we know the coordinates that are found at the end of this line AB, it means now we can use those coordinates to find what? The length. We know that there's a formula that we use when we are looking to calculate for a distance or the length of a particular line segment. So we know that we use the distance formula. So in this case, since it is the length of AB, I'm going to write AB, it's equals to, so AB here is going to be equal to the square root of x value of B minus the x value of A squared plus here the y value of B minus the y value of A. So now we substitute, right? So since now we have written our distance formula, we now substitute by the values. So the x value of point B, so the x value of point B, it's 12. Then the x value of point A, it's minus, it's 4. So we say minus 4 here, then we square. Then the y value of B, the y value of B in this case, it's negative 4. And then the y value of A here, the y value of A, we say this is 4. And then we square here, don't forget, and then we should extend this line up until it covers everything here. So now we know this is what we have. So 12 minus 4, we are going to get 8, and then 8 squared, we are going to get 64. And then negative 4 minus 4, it's negative 8. So negative 8 squared as well is going to give us 64. So from this, now what can we say about this? It is that this amounts to square root of 128, right? So remember, it was said that we should write our answer or correct our answer into 2 decimal places, right? So meaning that now we have to put this in our calculator, and then we are going to get that we are going to get that it is approximately 11,31 units, right? So this is what we usually do when we are looking for the length between 2 points, or the distance between 2 points, right? So we use the distance formula when we have those coordinates that belong in this line. Just like here, we have those two coordinates that belong at both ends, right, from this line. So we can use that. We substitute those points here in our distance formula so that we get our distance here. So we are done with 3.1. So let's now move on to our next question. Alright, so now we are on to our next question, which is 3.2. So 3.2 here, it says that we should determine the coordinates of D, which it is the midpoint of AD, right? So we know that D, it is the coordinates that we are looking for, which is the midpoint of AB. We know that there's a formula that we can use when we want to determine the coordinates that are the midpoint, right? So we are going to say that D here is a midpoint. We know that D here, it is a midpoint, so we are going to say that D, and then we say that x b plus x a divided by 2, and we say y b here, y b plus y a divided by 2, right? So this is what we use. And then normally, remember, we normally use the letter M, right? So but then since now we know the letter of the midpoint here, which is D, so we are going to use D here. So we say D, then we say xb here, which is the x value of B, we say it's 12. Then the x value of A here, we say it's 4. Then we divide this by 2. Then the y value of B, here, it's negative 4. And then the y value of A here, it's going to be 4. So we divide this by 2, right? So remember, these are our points of interest that are going to help us determine the midpoint of D. So go on further, that D here is going to be, so here we have 12 plus 4, so 12 plus 4, 16, and then 16 divided by 2 is going to give us 8. And then negative 4 plus 4, it's 0, and then 0 divided by 2, we are going to get 0 here. So therefore, the coordinates of D are 8 for the x value and 0 for the y value here. So this is how we actually determine the coordinates of the midpoint. So remember the formula, we substitute, and then after substitute, we simplify everything that's found here, and then now it's going to give us the y and the x value of the coordinates D. So that's what we have for 2 marks. Alright, so now we are on to 3.3. So 3.3, it says that we should determine the equation of line DE, right? So let's quickly highlight the line that they are referring to. It's line DE, right? So what do we know from line DE? We know the fact that line DE, it is parallel to line AC, right? We know that this particular line here, which is line DE, it is parallel to line AC. So what does that imply? It implies that the gradient of AC, it is equal to the gradient of DE. right? So this is what we know, right? We know that this is since what? Since what? Since DE is parallel what? It's parallel AC, right? So this is what we have. And then another thing that we know about line DE, it is the coordinates of D, that the coordinates of D, it's 0 and 8 here. It's 8 and 0, I mean. So these are the coordinates of D. So we know that if we can find the gradient of AC, then we are going to say that the gradient of AC, it is equals to the gradient of DE, since DE is parallel AC, right? So let's quickly write that. So we are going to look for the gradient of AC. The gradient of AC, we are going to use that. We have the y value of A minus the y value of C divided by the x value of A minus the x value of C. And then from these, what's the y value of A? The y value of A, you can see that is 4. Then the y value of C, you can see it's minus 4 here, so say minus 4. Then the x value of A here, you can see that it's 4. And then the x value of C here, you can see that the x value of C, it's -1. And then this is how we go about this. Now you can see -4 minus -4. We know that we are going to have a positive here, so it's more like 4 plus 4, which is going to give us 8. Since negative times negative is going to give us positive, right? So here we have 4 minus -1, so negative times negative, it's positive. So we are going to have 4 plus 1. So 4 plus 1 is going to be equal to 8/5. So now that we have found or determined the gradient of AC, so remember this is the gradient of AC, right? We can now say that therefore the gradient of DE is equals to 8/5, right? So remember this from this statement that we have said here. So now we go on further. So now we have the gradient. And then what do we know from this line DE now? We now know the gradient. We now have 1 point, right? So there's this formula that we normally use when we have 1 point and the gradient, right? So to find the equation, so we are going to say that y minus y1, it's equals to m over x minus x over 1, right? So we know that y1 and x1, those are from the coordinate D, and then now we have our gradient that it is equals to 8/5. So looking at this graph that we have here, it is because we can use this because we have a gradient and 1 point, meaning that we can use this equation here. So we are going to substitute by point D. So we know the gradient, that it's 8/8. So it is important that we know that we are going to sub by point D, right? So we know that we have to sub to this equation by, we sub D, right? We sub D into our equation, right? So that we have y minus, what's the y value of point D? We know that the y value of point D here, it's 0. And then what's our gradient? Our gradient, we know that it's 8/5. Then we say x here. And then what's the x value of D? The x value of D here, it's 8. So this is what we have, right? So from this, we are going to say y minus 0, it's going to give us y. Then 8/5 multiplied by x, we are going to get 8/5x. Then 8/5 multiplied by -8, we are going to get, you know that 8 times 8 here. What's 8 times 8? 8 times 8, it's 64. So 64 over 5. So this is what we have for this particular equation here, guys. So now we are going to move on to our next question. Okay, guys, so now we are on to 3.4. So 3.4, it says that we should calculate or determine the coordinates of E, right? The coordinates of E. So what do we know? We know that line point E belongs in line CB. At the same time, it also belongs in line DE, right? So we know that, and then now what we can do, we can use, there are about 2 methods that I can think of to do this. So looking at this, we are going to start with the one that we have to use, what? The midpoint theorem. So the midpoint theorem, how is it that the midpoint theorem? So looking at E here, we can see that E here, it is what? It is the midpoint of CB, right? So we can say that E is a midpoint. E is a midpoint the midpoint of CB, right? We are saying that E, it is the midpoint of CB. And then how did we actually get to this? We know that it is through the midpoint theorem. Then how do we get to that in conclusion? Remember here we have this line segment here, this line segment. Let me quickly highlight this. We have this line segment, which is line segment DE. Line segment DE bisects one side of the triangle. It bisects this side here, this side AB, meaning that it is cutting AB into 2 equal parts. We can see this by this, right? So now we are sure that line DE bisects line AB. And then moving from that, we can see that line DE, it is also parallel to the second side of the triangle, which is line AC. So that's the second thing that we have. So what can we say about this line segment? We can see that this line segment, which is line segment DE, it bisects the first side of the triangle. At the same time, it is parallel to the second side of the triangle. What can we say about this triangle? We can also state that this line here, line segment DE, will also bisect the third side of the triangle, right? Hence why we know that D, it is going to be a midpoint of what? It is going to be a midpoint of CB. So how can we write this? We can say the reason for this, we know that the reason for this, it is going to be the fact that we have what we have here. Remember, we have a line, that bisects one side of a triangle. At the same time, that particular line, it is and parallel, right? It is parallel to the second. Okay, right, second here, the second side of the triangle, right? So we can say that E is a midpoint of CBY because we have a line that bisects one side of a triangle and parallel to the second side of the triangle. So we know that this is the midpoint theorem. So this is the midpoint theorem. So this is the midpoint theorem, guys. So, and then now we can continue from this. We know that E, it is the midpoint, right, of CB, meaning that we can say that, can use this formula now that we are sure that A, it is the midpoint of CB. So we can say E here, and then say X B plus X C divided by 2. Then we can say Y B plus YC divided by 2. So this is what we have here. And then we can say E here, and then we are going to substitute by the values of X and the values of C here, so that now we are going to have the X value of B, the X value of B is 12, the X value of C, now we know it's -1, then we are going to divide this by 2, then the Y value of B, the Y value of B, it's -4, then the Y value of C, it's -4. So have positive here, so we are going to divide this by 2, and then this is what we have. So say E here, and then we are going to say 12 plus -1, 12 plus -1, we know that this is going to give us 11 divided by 2, and then -4 plus -4, this is going to give us -8. So -8 divided by 2, -8 divided by 2, this is going to give us -4. So those are the coordinates of E when we are using the midpoint theorem. So now let's quickly look at the other method that I was referring to. So looking at this diagram that we have here, we have this. So let me just erase this a moment. So let me just erase this part here and this part here, so that we can have a little bit of a clean diagram here. So let's do this. So now we are going to use the fact that this line CB here, it is perpendicular to the y-axis. Then how do we actually see that? We see this, that this value of the y value of the C coordinate here, the y value, it is -4, and then also looking at this value here, it is also -4 here. So this actually means that this line CB, it is actually perpendicular to what? To the y-axis. And then another thing that we can say that it is that the y value of E here, it is also going to be equal to, -4 as well. So now that we know the y value of point E here, which is this point here, what do we know from line DE? Remember that previously we found that the equation of line DE, it is y, it's equals to 8 over 5 x minus 64 divided by 5. So this is what we found. So meaning that we can sub by this value here, we can sub by the y value of E here, so that we can get the x value of E here, right? So going forward now, if we were to use this, we are going to sub this to here, we are going to get -4, and then we have 8 over 5 here. Then we are going to look for the coordinate of x, which I know that this is the x coordinate of point E. I don't have to write E here, so I'm just making point here, so that we have 64 over 5. So 64 over 5 here divided by 5. So this is what we have. Then remember, now we have an LCD here, an LCD which is 5, an LCD which is 5, and then remember I usually say that to remove the fractions we must multiply this side by the LCD which is 5. We are also going to multiply this side by 5. Why is it important that we multiply it by 5 both sides? It is because we know that we have to solve for x. Then we have to eliminate the fractions that we have here. So multiplying by 5 will eliminate the fractions that we have. So on the left hand side, 5 times negative 4, it is going to give us negative 20. Then while on the right hand side, when we multiply the first part here, 8 over 5 times xe, when we multiply it by 5 here, we are going to get 8 over x, right? And then another thing that we know, we multiply this 64 over 5 by 5. These 5 and the other 5, and they are going to cancel, so that we are going to have negative 64, right? And then so now we further go on to say that negative 20 here, and then we have this negative 64. So we can transpose this negative 64 towards to the right hand side. So when we transpose this towards to the left hand side, we are going to have negative 20 plus 64. So negative 20 plus 64, we are going to get 44, and then we have 8 here, which is 8x. So now we know that we have to divide both sides by 8, so that we are going to have x here, we are going to have 44 here divided by 8. Then from these, remember from this, what is that we are going to get? We are going to get x, it's equal to, remember, the common factor of 44 and 8 is 4. So how many times does 4 goes into 44? 4 goes there 11 times. And then how many times does 4 goes into 8? It goes there 2 times. So we can see that the x coordinate, or the y value of point E, the x value of point E here is 11 over 2. So meaning that we are going to say E has 11 over 2. And then remember that the y value here, we said that it is equals to negative 4. So we say negative 4. So if you can see that got the same answer as we got 11 over 2 and negative 4 from this. So we used both our knowledge of mathematics to actually determine these answers, so which are the same answers, by the way. So this is what you can also do, right? Given that that line, it is perpendicular to the y-axis.